I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we will discuss how do we solve trigonometric equation. It's a review and a very important review for students taking pre-calculus. Trigonometry is a very important part of calculus, so we should really have a command on it. In this series, we'll begin with basics and get into the complications soon. Here, we'll see how do we solve a trigonometric equation when a domain is given to us from 0 to 2 pi, and that is general. Now, measurements of angles will be in radians. In calculus, the measurements of angle are always in radians. As you can see, here are 10 questions. We'll simply begin with 2 cos x minus 1 equals to 0, the simplest of all, and end up with slightly complicated quadratic type of an equation in the first set of questions of 10. And then we'll take up the next set. Well, let's now focus on the very first set and try to answer them one by one. So as I explain you the solutions, I'll also briefly review the concepts, right, to brush up all the things required. So the very first equation for us is we need to solve the equation for x between 0 to 2 pi. Remember that. So 0 to 2 pi really means that we're looking into the coordinate plane, one full circle. Now, the equation given to us is 2 cos x minus 1 equals to 0. So rearrange, we get 2 cos x equals to 1, and therefore cos x should be equal to half. Now cosine is positive, so we should look into the cast rule, and we know when is it positive, right? Some of you might be using the unit circle. All the answers for these questions will have exact values, so we'll also review the special triangles as we move along. So cos x is half, so we are looking for something like this, right? Solution in quadrant 1 and in quadrant 4, right? So this is your quadrant 1, perfect. This is quadrant 2, quadrant 3, and quadrant 4. Now to find the angle, what we do is we look into the special triangle. Whenever you look into half square root 3 by 2, what are you reminded of? Well, this particular triangle whose sides are 1, 2 and square root 3, the angles being pi by 3, pi by 6 and pi by 2. Perfect. So you are reminded of this special triangle. You can see for cos of half, we are looking for adjacent over hypotenuse, and therefore the angle is pi by 3, right? So we know this related acute angle here is pi by 3, which is one of the solutions. The other one is related acute angle pi by 3 in quadrant 4, which will be 5 pi by 3, right? So we get the value of x as equal to pi by 3 and 5 pi by 3. Make sense? So these are the two values for which the equation will be satisfied. Now let's look into this second question, which is 2x equals to square root 3. You can now pause the video and answer this question. Well, let's rewrite. We have 2 sine x equals to square root 3. That really means that sine x is equal to square root 3 by 2, right? Again, the same special triangle, right? Where the angles are pi by 3, pi by 6, pi by 2, right? And the sides are 1 square root 3, 2. And we're looking into square root 3 by 2, right? And that too for sine function. Sine is opposite over hypotenuse. Some of you got over, right? Sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. Tan opposite over adjacent. So we're looking at the opposite side being square root 3, and therefore we can see very clearly opposite to pi by 3 is square root 3. And once again, we have the solution for us. The related acute angle being pi by 3. But what is the other angle? Well, once again, look into the cost rule. So these things go hand in hand. Positive solution means we are looking for these two solutions. One of them is right there, which is pi by 3. The other one is in quadrant 2, right? The other one is in quadrant 2. So we have two solutions, and this one is 2 pi by 3, correct? So we have the x values as pi by 3 and 2 pi by 3. Perfect, makes sense, right? Let's move on to the next question. So I hope it is simple. Next one I've taken as tan x equals to 4. Tan x plus 4 equals to 5. So we have this question here. You can actually pause the video, answer. Rearrange. So taking x on the 4 on the other side, we get 5 minus 4. So we get tan x equals to 1. It is positive 1. Tan positive 1 means what angle? Can you tell me? Well, the related acute angle is pi by 4, correct? And the other quadrant is quadrant 3, right? So we have cost rule. And clearly you see that the angles here are pi by 4 and this one is 5 pi by 4. Perfect. And therefore we have x as equal to pi by 4 and 5 pi by 4 as our answer. Does make sense to you? Perfect. So I hope we're done the basic questions with sine, cosine and tan, and you have understood the whole concept. Well, in case you want to learn directly from me, you can send an email on the address given. Now let's continue with more questions where factoring will be now involved, right? So now we'll see questions where the factoring will be involved. The first one, which is question 4, is sine square x equals to 2 sine x. Now do not cancel signs, right? Otherwise you are cancelling the solutions also. Bring 2 sine x to the left hand side. So we get sine square x minus 2 sine x equals to 0. Taking sine x common, what do you get? You get sine x minus 2 equals to 0. Now that gives you two sets of solutions. One for sine x equals to 0. The other for sine x equals to 2. Now sine x is always between plus and minus 1. So that is no solution, right? But the first one, which is sine x equals to 0, will give you some solutions within this interval. Now note here, the interval is from 0 to 2 pi, where 0 is included, but 2 pi is not included, right? So make a note of this. So when it comes to sine x equals to 0, I will suggest look into the graph of sine function, right? So within 0 to 2 pi, I have drawn the graph, and clearly we have two solutions. One is at 0, the other one is at pi, correct? So we have the x values. For sine x equals to 0, x is equal to 0 or pi. Do you see that? So these are the two solutions. Do not include 2 pi, since you see we have not included 2 pi in the domain. So that's very critical. Perfect. So let's move on and take the next question, which is question number 5. I hope you got the concepts. Here we have 4 cos square x minus 3 equals to 0. Let's rewrite. 4 cos square x minus 3 equals to 0. So how will you simplify? Well, let's take 3 on the other side. So we get 4 cos square x equals to 3. Dividing by 4, we get cos square x equals to 3 divided by 4, and then square root, right? So we have cos x equals to, whenever you square root, make it plus and minus, okay? So square root 3 over 4. So that gives you what? Well, cos x is equal to plus or minus square root 3, and square root of 4 is 2, right? So we can write this. Now, that gives you 4 different solutions, because if you look into the coordinate plane, we are looking for positive and negative solutions, right? So when you see the cos rule, cos is positive in these two, but in the other two it's negative, right? So this time we'll make the special triangle right here, and we know that we are looking for square root 3 by 2, right? So the related acute angle clearly for cosine will be pi by 6, right? So we have these solutions, pi by 6. Do you see that? Let me make them here. So all these are solutions, right? So we get the x value as pi by 6, right? And then this one will be 5 pi by 6, 7 pi by 6, and 11 pi by 6. Makes sense? So we have 4 solutions for this particular case. Perfect. So that is how we are going to solve these questions. So we are already halfway. Now let's move on to question number 6, which is cos cube x equals to cos x. So let's factor bringing the terms together. Cos cube x equals to cos x. So we could write this as cos cube x minus cos x equals to 0. Taking cos x common, we get cos square x minus 1 equals to 0. So that gives us a couple of solutions, right? One, that cos x could be 0, or cos square x equals to 1. Well, cos square x equals to 1 really means that cos x could be equal to plus or minus 1, right? Do you see that? Now we are given the domain which is between 0 to 2 pi. So what are the solutions? Can you tell me? Well, let's also look into the graph of cosine function. So you see, slowly we are reviewing the whole trigonometry with the help of these examples. Now remember, since 2 pi is not included, we should not include that in our answer, okay? Perfect. So we are looking for answers where cos x is 0. 0 means pi by 2 and 3 pi by 2. And plus and minus 1 means 0 and pi, right? So that gives you all the solutions. So we can write x as equal to 0, pi by 2, pi, and 3 pi by 2. Do not include 2 pi since it is not in the domain. Is that clear to you? Perfect. Easy. So we have reviewed the special triangles, the graph of sine and cosine, the cast rule, SOHCAHTOA you all know, right? And now let's move forward. So now we have square root 2 tan x cos x minus tan x equals to 0. How are you going to solve it? Well, we should factor out tan x. What do you get? You get tan x within brackets square root of 2 cos x minus 1 equals to 0. And now tan x should be equal to 0 and square root 2 cos x minus 1 should be 0. That gives us two sets of solutions. Can you write these solutions and then match with my solution? Great. Tan x equals to 0 means x is, when sin x equals to 0, tan x is also 0, right? So x should be 0 and pi. About cos x 1 over square root 2, we are in quadrant 1 and in quadrant 4, pi by 4 and 7 pi by 4 are the two solutions. Perfect. So I hope now you get it. I'd like you to now try the questions after this yourself and then check with my solutions. So let's review once again and see where the solutions lie. So on the coordinate plane, we have pi by 4 and 7 pi by 4, which is quadrant 1 and 4. And then we have the points at 0 and pi for tan 0. Let's move on to the next question. 2 sine square x plus sine x equals to 1. Now this is a quadratic form of trigonometric equation. Rearrange and factor, correct? So you're looking for sum and product of minus 2, sum of 1, right? So you could write this as 2 sine square x plus 2 sine x minus sine x minus 1 equals to 0. Now 2 sine x is common in the first two factors. We get sine x plus 1, and here we have minus common, giving us sine x plus 1 equals to 0. Sine x plus 1 is now common, and we get 2 sine x minus 1 equals to 0. So that gives you two different equations to solve. First, sine x plus 1 equals to 0. That means sine x is minus 1. And sine x is minus 1 within this domain for which value? 3 pi by 2. So we have one solution, right? The other one we are going to get from 2 sine x minus 1 equals to 0. Or sine x equals to half. So let's draw this special triangle. Okay. So 1 square root 3, 2. Sine x is half for pi by 6. And therefore, but it is also half for in quadrant 2, right? So we have two solutions here. 1, 2, correct. So we have x equals to pi by 6. And we have x equals to 5 pi by 6. And therefore, we have got all these values. 3 pi by 2, pi by 6, and 5 pi by 6. Makes sense. So that is how, see, we can now solve the quadratic equation form of the trigonometric equation, right? Perfect. So I hope till now, no problems, right? Here is another question very similar to what we just did. I'd like you to pause the video, answer this question, right? So it is 2 cos square x plus 3 sine cos x plus 1 equals to 0. Sum and product 2 and sum is 3. So we can write 2 and 1, right? So cos 2 square x plus 2 cos x plus cos x plus 1 equals to 0. 2 cos x being 0 common. So we get cos x plus 1. Here 1 is common. So we get cos x plus 1. Cos x plus 1 is common. And we have the other factor as 2 cos x plus 1. So that gives you two sets. One is that cos x equals to minus 1. This is for this one. And the other one is 2 cos x plus 1 equals to 0, or cos x equals to minus half. Right. So for these, let's write down the solutions. As you know, cos x being half minus means you're looking for solutions in quadrant 2 and 3, right? This is for minus half. And for minus 1, we know cos x is minus 1 for pi, right? So x is equal to pi, that is for minus 1. And for half, again, we have this special triangle, 1, 2 square root 3, pi by 3. So we have related acute angle of pi by 3. So we have x value as equal to 2 pi by 3 and 4 pi by 3. So we have three answers. One is x equals to pi, second one 2 pi by 3, and then 4 pi by 3. Makes sense? Perfect. That is how you do it. Right. Now here is the last question for you, slightly tricky. Well, I hope you are enjoying this journey. In case you want to learn directly from me, feel free to send an email on the address given. So we have now a question, 2 sine square x minus cos x equals to 2. How do we solve this? Let's bring 2 to one side. which is left hand side, right? So sine square x minus cos x. And I'm bringing 2 on this side, rewriting the equation as this. Now you remember Pythagorean identity, which is sine square x plus cos square x is how much? Well, that is equal to 1. And therefore, I can write sine square x as equal to 1 minus cos square x. Makes sense. Now, because we have an equation, we should put only one trigonometric ratio. So therefore, we'll split sine square x as 1 minus cos square x and rewrite the other terms. So open the bracket, 2 minus 2 cos square x minus cos x minus 2 equals to 0. Now 2 and minus 2 will cancel, so we get minus 2 cos square x minus cos x equals to 0. So we can take minus cos x as a common, right? Okay, minus cos x is common. So we get 2 plus 1, 2 cos x plus 1. So that leads to the solutions now. So we have one solution for cos x equals to 0. That means x is equal to 0, right? And which value? Well, x equals to 0 means pi by 2 and 3 pi by 2, right? And the other one, we are looking for 2 cos x plus 1 equals to 0, right? Or cos x equals to minus half. So cos x is minus half as we did earlier. In the quadrant, 2 and 3, right? And the angle being pi by 3. Correct. So we have x as 2 pi by 3 and 4 pi by 3. We already have 2 more answers, so we have 4 solutions to this particular equation. Is that clear to you? Perfect. So for this equation, we have these 2 answers, and let me draw those 2 also. Cos function being like this, right? So those 2 answers. You get the idea. So that is how we get all the solutions. Remember now we get cos x, x equals to, for this term, as pi by 2, 3 pi by 2, 2 pi by 3, and 4 pi by 3. So I hope you have understood all the steps involved in solving trigonometric equations, right? Now with this knowledge, you can move on and take up the next set, where we are combining the primary and secondary trigonometric ratios in the equations. Still, the domain being 0 to 2 pi, where 0 is included, but 2 pi is not included. So I hope you find this series useful, explore more, and in case you want to learn directly from me, send an email on the given address. Thanks for your time and all the best.